Alright guys, so I'm going to do another example trying to be a little bit closer up for you guys to see. So in this case, we are writing the formula for an ionic compound. In this case, we are given the name and we are asking for the formula. So to do these kind of problems, you need to look for tin. Well, we know that tin is an element, so you're going to take your periodic table out and you're going to look for tin. Well, I know there's tin right there. The element is Sn. So I'm going to come over and I'm going to write the element's name. Sn. Well, tin is a transition metal. So I need to put the charge that was indicated. This charge is Roman numeral 2. Therefore, the charge is positive 2. I knew that it was going to be positive because tin is a metal. All metals will always be positive. Therefore, anytime you have a number in Roman numerals designating the charge of the transition metal, it will always be a positive number. The next thing you need to do is look at hydroxide. Okay, well, you're thinking to yourself, it ends in IDE, therefore it must be an element all by itself. Maybe hydrogen, I don't know. However, I told you guys in class that there are 3 polyatomic ions that end in IDE. Hydroxide, peroxide, and cyanide. So those are the 3 ones that I really wanted you guys to kind of memorize if you can. So since I know hydroxide is a polyatomic, I'm going to come over to the chart on page 220 and I'm going to look for hydroxide. So I'm going to get real close because last time you guys couldn't see it far away. I'm going to come down, there it is, hydroxide, right there. And the polyatomic is OH negative, hydroxide. All right, so I'm going to come back over and I'm going to put OH negative. Well, as it stands right now, positive 2 plus negative 1, remember, if there's just a little negative, that means that it's negative 1. Even if the 1 isn't there, we know it's negative 1 because a little line all by itself represents negative 1. All right, so positive 2 and negative 1 do not add up to 0. It is not a neutral compound. Because of that, I need to find the least common multiple. So if I pick multiples of 2 and multiples of 1, so multiples of 2, 2, 4, 6, etc. Multiples of 1, 1, 2, blah, 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 etc. Well, 2 is the least common multiple. So I need to multiply this number by something to give me 2. Well, 2 times 1 gives me 2. Negative 1. Well, 1, because it's negative 1, even though the 1 wasn't written, times 2 will give me 2. Whatever number you multiplied by at the very top, that number will become the number at the bottom in the answer. So my final answer for this guy should actually be, I'm going to put a little arrow because my final answer is actually tin, 1 tin, so tin, hydroxide, and how many hydroxides? 2. However, if I don't put parentheses around this hydroxide, I'm going to think that there are 2 hydrogens, and there are 2 hydrogens instead of 2 hydroxides. So in order for me to know that this 2 is telling me 2 hydroxides, I needed parentheses around the polyatomic. Also, if there's only 1 tin, I don't need to write the 1. The 1 is implied. So my answer for tin 2 hydroxide, the chemical formula is Sn parentheses OH parentheses 2. That is the answer for tin 2 hydroxide. Okay, coming over here. Let's say I was given the chemical formula and I was asking for the name. So we have to kind of do the backwards work. In this case, I have to look at the symbol and figure out the name of that compound. Well, if I look for iron on a periodic table, there it is. I told you the answer, excuse me. I'm looking for Fe. I can realize that it's iron. So I'm going to write that here. Iron. Before I move on, I need to ask myself, is iron a transition metal? In order for me to figure that out, I look at my periodic table. Well, anything that falls in this bracket here, from this group all the way over to this group, that's called my D block. Those are going to be transition metals. Iron is inside of the D block, and therefore it is a transition metal. Whenever it's a transition metal, you need to put parentheses, because we know we're going to need a Roman numeral to tell me the charge of that iron in the name. All right, for now I'm going to move on. I'll come back to that. At this point, NO3, that's inside of these parentheses, which tells me that this whole thing here is a polyatomic ion. Well, I know my polyatomic ions are going to be found on page 220. So I'm going to come to the chart on page 220, and I'm going to look for NO3. There it is, NO3. NO3 is called nitrate. So I'm going to come over here, and I'm just going to write the name. Nitrate. All right. Some of you might be asking, what about this 3 at the end? Don't I have to write anything for that? Well, we really don't. As long as you know that this is iron and this is nitrate, that's pretty much it. The only thing is, if it is a transition metal, which in our case iron is, we now need to look for this charge, because that is necessary. It's required. It's a part of the name. So to find the charge, we have to take the charge of the negative guy. Well, nitrate does have a charge. The only way I know it is by looking at the table. So there's nitrate, and the charge is that little line all by itself. What does that represent? -1. See, with a charge of nitrate, -1. We're going to do a little formula. Then I have to say, how many nitrates do I have? Well, I have 3 nitrates. This 3 outside of the parentheses tells me that I have 3 of whatever polyatomic is in here. So NO3 all by itself, that's just nitrate. I have 3 of these nitrates. So -1 times 3. And then I divide it by the number of metals. Well, my metal is iron, so I'm going to divide that by 1. And then I have to put it in absolute value because the charge of a metal must be positive. -1 times 3 is -3. Divide by 1 is -3. And the absolute value makes it positive, so it's +3. So I'm going to put this +3 as Roman numeral 3. And that is the name, iron 3 nitrate.